So today, I'm going to give you a bit of a journey that we've undergone in Vapor and kind of give you some tips and tricks to help you when you're migrating large code bases without breaking the world. And hopefully by the end of this talk, you'll have some things you can take back to your code bases to make it easier to maintain and more fun to work with. So as mentioned, I run a company called Broken Hands, and we do server-side Swift training and consultancy, so basically helping companies deploy Swift on the server. But I'm better known as that Vapor guy. I'm one half of the Vapor core team, so I'm responsible for building, maintaining, and evolving the Vapor framework. I sit on the Swift server work group and the Swift website work group, so if you have questions about that, feel free to ask. And I'm part of the server-side Swift team at Codebases. And I also organize a couple of meetups in the UK and the server-side.swift conference, which is in September this year. So if you have any questions afterwards, there is the Ask the Speaker session. But if you miss that or you have something that comes up later, feel free to reach out to me as 0xTim on pretty much all social media. So go for it. So before we get into how to avoid making breaking changes, we need to discuss what actually are breaking changes, because they mean different things to different people. And in the software world, and certainly in the kind of library dependency world, we've kind of centered around semantic versioning. So for those of you who don't know, semantic versioning is a specification for defining what version numbers mean in your packages. And it's comprised of three parts, 1.2.3. So the first part is the major version, and this denotes breaking changes in your code base. So you know if you're updating from 1.2.3 to 2.0.0, that there will be breaking changes and your code may not compile. The middle section is the minor part, and this denotes new APIs. So it might be new features you can use, new functionality, but your existing code will continue to compile when you're depending on that library. And the final part is the patch section, and this denotes internal changes, bug fixes, updating dependencies, stuff that generally you're not going to see, but there are changes that you should probably take. And in semantic versioning, breaking changes are defined as changes that make your code no longer compile. So you can add new features and stuff, and in Swift this is very easy, but if you put in an update and your code no longer compiles, that's considered a breaking change. And that's how we kind of consider things in Vapor as well. So for those of you who've not heard of Vapor, Vapor is a framework for writing server applications, APIs, backends, command line apps in Swift. And it's pretty big these days. We currently have about 77 repositories, of which 2/3 are currently active. And within those 50 or so repositories, we maintain about 400,000 lines of Swift code that we actively maintain and keep up to date. And to give you kind of a bit of a brief overview, we need to step into Time Machine here, for anyone who remembers that graphic, and look back where Vapor's come from. So the first commit was back in 2016, January 2016, and Vapor's undergone quite a rapid change since then. So after 2016, when the first commit was, Vapor 1 was out in September 2016, and then in May 2017, Vapor 2 came out, then Vapor 3 came out in May 2018, and it was a very rapid iteration. And so we took a bit of a break, and then Vapor 4 was released, which is the current version, in April 2020, so almost 4 years ago, which means that code that you wrote back in April 2020 targeting Vapor 4 will still compile today and still work today. And that's no easy feat, it has to be said. In the time since Vapor 4 was released, we've made 266 releases of the Vapor project. As of a few weeks ago, there have actually been a few more releases. And we really like quick, small releases, because it's very easy to say what's broken if you do lots of small releases rather than big bang releases, building up 6 months worth of work, and then something doesn't work. So we're a big fan of doing small releases, and we use a lot of automation to basically, as soon as a pull request is merged, we tag it with a specific label, and that automates the release and tagging of the thing in GitHub. But back when Vapor 4 was released, things were very different. So Swift was on 5.2 since then, and since then we've had 8 major versions of Swift, I say major because Swift doesn't really follow semantic versioning, unfortunately. There was no async await. There was no sendable, no macros. And a lot of the libraries that we rely on the ecosystem didn't really exist. So things like tracing and metrics and argument parser, they didn't exist back in the day. And we've managed to adopt and evolve and incorporate a lot of these changes without breaking the existing API. And there's two big changes that I want to call out. The first was 4.50, which was the release that supported async await. And this was where we finally managed to get away from event-linked futures. If anyone's tried to use Vapor, you'll know the pain that was. And then 4.86, which was the first release where Swift was Vapor was fully sendable. So that meant that you could build a Vapor project and have no warnings with strict concurrency checking turned on, or complete checking turned on. So how have we gone about doing this? So there are a number of tricks and tips we've used. Some of them are very simple. So to start with, default parameters. So many functions need to change and evolve over time. And in this instance, we have an initializer for a type, and we wanted to add a new log level. But if we just add a log level that takes a string, that's a breaking change, because anyone who now calls that initializer won't be passing in the log level. So in Swift, we have default parameters, which means that we can change our code to look like this, and anyone who has the existing call site will just get the default parameter and the default log label. And they are able to opt into the new API if they want to use it. I will note that this is technically a breaking change because anyone who is relying on the function signature might see compiler issues, but in Vapor we don't consider that a breaking change because it's quite an edge case. How about new protocol requirements? So in Vapor, we are a big fan of protocols. Everything's a protocol, which I'll come on to later. But if we add a new function in a protocol, let's say, where we want to do something new, how do we do that without breaking existing codebases? Because anyone who implements that protocol will then also need to implement the new functionality. When in Swift, we have protocol extensions, which allow us to define default implementations. So we can actually write an extension for the new function, which means anyone on the old version will get this for free, and their code will continue to compile. And these two features of Swift make it very easy to evolve and update your code bases. And this applies both for building libraries and packages and also applications. As applications get bigger and bigger, you tend to want to break them down into smaller pieces and modularize them, which is the buzzword of the day. And essentially, you're building small packages and small libraries for your applications. One really useful feature is the availability annotations in Swift. So a release of Vapor a couple of years ago now provided a new property on our roots type called case insensitive. Now, the eagle-eyed amongst you will notice we actually spelt that wrong, and it got through 2 rounds of review with a spelling mistake. But we can't just change the spelling to fix it because people are now relying on that API. So what we had to do is release another version with the correct spelling and deprecate the badly spelt one. But the deprecation functions in Swift using the @available annotation allow us to provide the renamed property. So if we have a look here, you can see that we can actually, there we go. I'm on the wrong screen, I'm gonna have to look here. There we go, okay. So you can see we're actually passing in a rename parameter here. And that tells the compiler that the new type is called this. So it will actually suggest to fix it. So if you see down at the bottom, Xcode will provide a fix-it for you, which you can then click to automatically update to the newer API. But this isn't an error, this is a warning, which is an important distinction. If you have types or deprecations that don't make sense to have renames, you can provide a longer message using the message function. Let's talk about enums. Enums in Swift are incredibly powerful and really, really featureful. If you're writing libraries, you can't really use them. In fact, you should not use them at all publicly. You cannot have public enums, because as soon as you add a new case, that's a breaking change, because anyone switching over that enum will no longer be switching over all the different cases. Now, there is a feature in Swift called non-frozen enums, but unfortunately, it's not available to us developers. If you're writing Apple or internal Apple frameworks like Swift UI or Foundation, you get access to non-frozen enums. If you're writing public stuff, you don't, which presents us with a problem. So in Vapor going forward, we basically put a blanket ban on enums, public enums. But they're still really powerful, and we still want to be able to use them. So what we do is we have a type with static definitions that are backed by an internal enum. So in this case, this is the error type from our JWT library. You can see here we have static properties that match our internal enums. So this allows us to use all of the functionality of Swift enums, but only expose static properties publicly, which allows us to add new types without breaking the existing API. And this is a really powerful little feature that I highly recommend anyone writing public code to adopt. Another little unknown feature of Swift is the disfavored overload annotation. So in this case, we've added a new type for computing headers. But from the compiler's point of view, these two types, or these two functions, sorry, are exactly the same. And it might not be clear as to which one you actually mean. And this can produce warnings or unexpected behaviors. So you can actually annotate it with a @_disfavored overload. And this tells the compiler, don't use this one if there's another one available. And it's another little nice trick. So this is all well and good, and all these tips and tricks. But how do you actually tell if you have broken your API? There is an unknown or little-known feature in Swift Package Manager called the Diagnose API Breaking Changes checker. And it's built into Swift Package Manager. And it allows you to pass in a Git branch, and it will check your code to see if you have any breaking changes from a public point of view. And we run this on our CI, so any pull request must pass this. Well, it should pass this. It's not perfect. It doesn't pick up some of the rather weirder edge cases, especially around Sendable. But for the most part, we must make sure that we're not breaking the API. And this is a really useful tool for you to use to make sure you're not. And so you can see here, we've run this against our Postgres library, where we removed one of the setters. And that's a breaking change, because people might be relying on that. And so this is a really good way of picking up those things. OK, so we now need to look at how we're kind of evolving for the future. Swift 6 is the next major version of Swift after 5.10. And whilst it will be possible to build older libraries and modules and targets using the 5.10 or 5.9 language mode, Swift 6 is something that we want to support. We want to be able to support it now rather than just when Swift 6 is released. And essentially, the big focus on Swift 6 is Sendable. And sometimes it can kind of feel like you just have to mark Sendable everywhere. But it is a big focus. The good news is that adding Sendable to most types just produces warnings and not errors. And when I say it produces warnings, it can produce a lot of warnings. But they aren't breaking changes. And that's the important thing here. We're fine with warnings because it means people can migrate and still ship code if they have to. But it's not going to break their code, and that's the really important distinction here. One little nice feature of adopting Sendable in your APIs is the @pre-concurrency annotation. And this tells the compiler that this API existed before Sendable was a thing, essentially. So don't warn on this type. So if a consumer of your API is passing in a non-Sendable closure in this instance, they won't get a warning unless you've turned on strict concurrency checking. So this is a good way of stopping your users getting littered with warnings when you adopt Sendable. So to enable Sendable checking, if you're building iOS applications, it's a project setting, and you can turn on per target as well. So if you have lots of different modules, you can turn it on incrementally for each module. By default, it's targeted, but everyone should be turning it on to complete these days because time is running out. If you're building packages, you set a experimental feature in the Swift settings. Now, the one downside of this is that Swift experimental features are only available in 5.9. And in Vapor, we support 5.8 currently, and used to be 5.7. So how do we get around supporting different versions of the language? Well, if you're writing Swift packages, you can actually have different package versions for different languages. So we duplicate our package, package.swift file, and we have one which is our main one, and then we have one which is for 5.9 and above. And Swift Package Manager is clever enough to work out which one it should use, and it will always pick the latest. So if you need to support experimental features, you can have a 5.9 manifest and a regular manifest, and still support the old features. Now, in terms of dropping support for different languages, it's very easy to do. So if you support 5.7 and you want to jump to 5.9, you can just change your Swift Tools version to 5.9. And this is OK. This is not a breaking change, because Swift Package Manager is clever enough to work out that if it's running on 5.7, it can't take the version that has 5.9. And it will take the latest version that it currently works with. So that's a great thing. Platforms, on the other hand, are slightly more complicated. If you want to update your platform versions, you cannot do this. This is a breaking change. So be very careful when you're adding support for platforms, because you're sticking with it for as long as you have that major version. Now, one of the things that's really helped us over the years with Vapor is having a good, well-defined architecture. And it has allowed us to evolve and adapt as we've grown and has supported new features. And from what I consider a good architecture, there are many different names for it. It could be hexagonal architecture, it could be ports and adapters, it could be protocol-orientated programming. They are all the same thing, essentially. And it's a way of abstracting away your dependencies and your third-party libraries and your APIs away from your business logic. So what do I mean by this? Well, let's imagine you're building an application for checking the weather. You're going to need something that goes out and gets the current weather. Now, if you put this behind a protocol, such as here where we have our weather API, you can have different implementations. And you can define the API that you want to use that makes sense for your application, as opposed to being forced to use the API that your dependency has. And then we can have an implementation for, say, WeatherKit that implements that protocol, but it's all done within that protocol. So your business logic just calls the API that you want to use. This makes it really easy to change in the future. So let's say your app gets really popular, and you're all of a sudden getting a big bill because you're calling WeatherKit lots and lots of times. So you want to put it behind an API that caches the results. If you have a design like this, or an architecture like this, you just need to change that single implementation of that protocol, and the rest of your app does not need to change. So we can change it to call an API instead. And the added benefit of this is it makes it very easy to test. Because everything's done via protocol, you can have a test implementation of the protocol and write your tests for that. OK, so that's all well and good, but at some point you do want to make breaking changes. And at what point do you make a major release? And frankly, there's no good answer. It's a balancing act between having an accumulating tech debt and annoying your users. So as a user, you don't want to have to update your dependencies and have it break all the time. The longer that it stays stable, the better. And the better your code is going to be used, and more popular it will become, and more faith people will have it. And this is something that Vapor had issues with early on because we were very small and young and growing quickly. We changed a lot and evolved quickly. But over the last 4 years, we've had this stable API. But that means we've been accumulating a lot of tech debt over the last 4 years. And we're now kind of getting ready to be able to change. And the scales are definitely shifting towards tech debt. And essentially, it just requires a bit of planning. So make the plans and decide when it makes sense for you to make those breaking changes. There is no right answer. Thank you very much.